D block elements part 2. Let us start with this question. Why copper, mercury, gold, palladium, platinum does not dissolve in acid? The same question can be asked us why these elements does not liberate H2 from acids, right? To answer this question, we have to understand about this standard reduction potentials. Standard reduction potential means the potential developed by an electrode. Potential developed by an electrode at STP, at standard temperature and pressure. Right. We will read in advancement in while reading our electrochemistry. So this is enough here right now. So look at these stabilizations. These are the values experimentally verified and tabulated here. Right here, hydrogen has a zero neutral. This is a zero value. Some elements will have positive value than the hydrogen. The point is, if the standard reduction potential is greater than hydrogen or greater than zero, whatever it may be, these metals cannot displace hydrogen in solutions or in acids, right? That is, the greater than the hydrogen in sense positive value, positive E naught value, positive standard electrode potential values. If it is that they are not able to displace hydrogen in solutions, right? The same in the case of opposite. If it is negative, if standard electrode potential value is lesser than the hydrogen or negative, they can displace hydrogen. They can displace hydrogen from solutions, right? Now, listen here, come to the table here. Here, these things, let us take copper here. The copper is having the value of 0.34. That's a value higher than that of the hydrogen. So, this copper cannot displace hydrogen from the solution, right? Consider zinc here, zinc minus 0.76. So, that is having the lesser value than the hydrogen. So what happens here? The zinc can replace hydrogen from the solution. Let us write the equation. That is copper plus HCl. The reaction does not take place. No reaction. Because the E naught value that is equal to plus 0.34. So for hydrogen, it is 0. So it is greater than hydrogen. It is not possible. But in the case of zinc, zinc plus HCl, that gives ZnCl2 plus H2, right? ZnCl2 plus H2. So here this is possible because the E naught value is negative. Here, check out for zinc, I think it is minus 0.76. 0.76. So this is the reason. And we have to understand this table perfectly. Right, listen here. This is most important here. Now, let us understand this table perfectly so that it will help us a lot in solving much more problems in DF and as well as in electrochemistry too. Right. Now, try to understand that when we are moving from top to bottom, sorry, bottom to top here. First, let us start from bottom to top, this area. Bottom to top, we have to understand here, this arrow, we have to understand the strength of oxidizing or the oxidizing power increases. right? So here lithium has the least value and fluorine has the highest value. Lithium has minus 3.04 and fluorine is 2.87, right? So the minus negative value will have the lowest oxidizing power, right? While we are going to the top, the oxidizing power increases, or it acts as an oxidizing agent. So here, oxidizing agent, in sense, what does it means? It itself get reduced, right? Is it clear? Oxidizing agent means that facilitates oxygen. Let me write it clearer for you here. Just a second. So, oxidizing agent. First, we should be clear about what is oxidation, reduction, oxidizing agent, reducing agents, everything, so that it will be easy for us to decipher this table. And while doing the problems, we can remember the values, important values of some elements, right? So, let me make it clear first. First, oxidation. Oxidation is nothing but loss of electrons, right? OIEL, oxidation loss of electron. Reduction is nothing but gain of electrons, or IEG, reduction is gain of electrons. Right? This we all know. Oxidizing agent in sense, oxidizing agent, that means it facilitates oxygen and itself get reduced. Itself gets reduced. And reducing agent it means it facilitates reduction and itself gets oxidized. So this is a point where we should be clear, right? So now we are talking about the stronger oxidizing agent in the sense it gets reduced easily, right? It gets reduced easily, right? And weaker oxidizing agent in the sense it does not get reduced easily, right? Am I clear?